I would like to invite Professor Dr. Opim Sitompul as the Dean of Faculty of Computer Science and Information Technology, Universitas Sumatera Utara, to give an opening speech for this event. Professor, the audience is yours.
Thank you, Pak Jos. Today is our first of the series for the world-class visiting professor. We have an honored guest, Professor Dr. Rahmat Budiarto, who will give us some view on AI in healthcare, specifically to assist poor setting community in combating COVID-19 pandemic. I hope and I know this is a hot topic right now. Not only for the pandemic case, but for AI in healthcare in general. So I hope all the students can take this opportunity to dig deeper on these topics, because many of us has performed some research, especially in this healthcare domain. So for this opportunity, maybe we can further enhance our knowledge, and the most important things is how we can collaborate, especially for with Professor Rahmat Budiarto of with Al-Baha University in general. Especially, we will take this opportunity to discuss further later with Professor Rahmat Budiarto. In this case, I hope our Dean, Vice Dean in Research and Collaboration, Ibu Maya Sylvie, can take this opportunity to support our research and collaboration with another university. And as I said before, we will take this opportunity as a first step to collaborate with Al-Baha University, especially with Professor Rahmat Budiarto. I think that's all. Thank you very much for coming in virtual to Universitas Sumatera Utara, especially in Faculty of Computer Science and Information Technology. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Thank you, Professor Opim, for the opening speech. Now we are going to begin the presentation for the general lecture, but before we begin the presentation, allow me to introduce our presenter for today's lecture. Professor Rahmat Budiarto is a professor at College of Computer Science and Information Technology in Al-Baha University, Saudi Arabia. He received his bachelor degree in mathematics from Bandung Institute of Technology, and both his master and doctoral degree in computer and electrical engineering from the Nagoya Institute of Technology in Japan. His research are in intelligent systems for data mining and knowledge discovery, data science, brain modeling, intelligent network monitoring system, cybersecurity. Apology. Sorry, there's a little lag in my computer. Okay, cybersecurity and next generation networks. He has published over 288 publications during his career, including books, book chapters, international journals, and proceedings. He has also received numerous awards and grants during his career and involved in numerous international conferences as organizers, including our own conference series, the International Conference on Computing and Applied Informatics. Thank you, Professor, for your continued support in our conference. Today, Professor Rahmat will have his presentation, and before we begin the presentation, I would like to remind the audience that there will be a question and answer session after the presentation. Feel free to write your question in the chat room during your presentation, and I will sort and list them to be answered later. Without further delay, please welcome our speaker for today's lecture, Professor Ratmat Pudiarto. The audience is yours, Professor.
Thank you so much, Bang Jos, for introduce me. And then, okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Very good afternoon, everybody. First of all, I would like to thank the Dean, Prof. Opim, to invite me, and also Vice Dean, Dr. Maya. And I'm so glad to be here virtually. So okay, I cannot share the screen.
Wait, let me try to figure it out.
Yep.
I think you should have able to share your screen by now, Professor.
Okay. Where is my slide? This one. Okay. How to? Yeah. Okay. Can you see my slides?
Yes, sir. You can see your slide.
Oh, sorry. Okay. So, as introduced just now, today. Sorry, I think this is wrong. Sorry. Oh my goodness. Give me a minute.
Okay, Prof.
I mean this one. Can see my slides now?
Yes, sir. It's
Okay.
correct slide now.
Okay, thank you. Yeah, I hope I can finish my talk, my slides within 15 minutes or 1 hour, because it's quite long. I prepared this talk for 2 hours talk, and hopefully I can finish, but maybe I need to go fast in some places. Okay, so this is the agenda for my talk today. I will start with introductions, and then we talk about healthcare, followed by artificial intelligence, some projects we are doing and we have done. We want to share about this, and we discuss a bit on the potential collaboration projects. Okay, now I'm in with Al-Baha University in Al-Baha City. Al-Baha is the smallest province in Saudi Arabia. It is about 300 plus kilometer from Mecca, in the southwest of Mecca. It takes, I think, 4.5 hours drive to go to Mecca. Yeah. So maybe it's difficult for you to believe that Al-Baha is surrounded by a green area. Yeah. So we are in hilly area. And we have also these plantations, bananas. So I don't miss it. I can have it here. And this is a view of Al-Baha icon for tourism. It's called Ziain village. It's very old village. Also green. And today's weather is still nice, 12 degrees Celsius in the morning. So this all about Al-Baha. I stay here, I move here in 2014, yeah? Beginning of 2014. So this is my 6 years here. Okay, let's start with this statement from WHO. Yeah. So even though we are in the pandemic, but the WHO stated that uh, all countries in the world need to achieve the optimal balance between fighting the COVID pandemics as well as maintaining essential health services. Meaning that other patients, other people that suffering from other disease, we still have to serve them equally. Yeah. So even though the focus in the pandemic, but other disease, other problems in health or medical still have to be uh, served equally. Yeah. So, and then, even though the network is not so good recently, but uh, almost all governments in the world try to increase the penetrations of internet. So they believe that internet penetrations in rural area uh, much better compared to the past. That's why they start to use this online medical service. There are so many. I just take ones in Indonesia. I believe you know these applications. Hello Doctor. So clients or patients can virtually discuss on or consult to physicians and receiving uh, what they call prescriptions and can also buy the medicines online from this portal. Yeah? So many application already using apps, and we don't need to physically meet up with the doctor. Okay, so even though we have the such applications, mobile apps, but there are so many limitations uh, with the healthcare in a resource poor setting community. Yeah? So I just mentioned two here. One is inefficiency in the healthcare delivery system that causing unnecessary long waiting times for the patient. It's happened even here in Saudi Arabia. And also limited resources that causing also many unnecessary and redundant processes. Yeah, paramedics check, and then the doctor checks, the specialist check. So this one also lead to a greater delay in treatment process. Yeah. The second limitation is on the implementations of the mobile health application itself, especially for resource poor settings community in developing countries. So the current mobile application is too general. It's not specific for rural area, which is has less infrastructures, less human resource, and so on. Okay, if we look at our neighbors countries, Malaysia, more than 20 years ago, they already see their features, with their Wawasan 2020. Yeah. So they set that the country will be a nations of healthy individuals, families, and communities. Yeah? So these are some characteristic of their healthcare system. Uh, should be equitable among the what citizens, yeah? Affordable, efficient, technologically appropriate, environmentally adaptable, and consumer friendly. And with all these characteristics, they emphasize on quality, innovations, health promotions, also to other countries. Yeah? Respect for human dignity, promotions of individual responsibility, as well as promotions of community participations. Okay, so we move now to healthcare engineering. Yeah. According to Chiu, Healthcare engineering is the merging or combinations of engineering disciplines and health science. Yeah. Engineering including biomedicals, chemical engineering, computer engineering, software engineering, and so on. And health science that include medicines, dentistry, allied health, nursing, pharmacology, public health, etc. So the definition of healthcare engineering is actually combinations between healthcare or medical sectors of all engineering disciplines and the engineering or technology sectors of health science. So this is the scope of healthcare engineering. So because we are from IT, we are from computer science, so we are going to contribute to healthcare or health science domains. Even though healthcare engineering is relatively new, but it's already contributes to healthcare industry. So in some sectors, I just take some of these. For example, here in healthcare services, system and equipment, the healthcare engineering already contributes towards the creations on and development of hardware, software to innovate, to improve, and to optimize the operational process of the system uh, of patient's care. Yeah. Of course, this one improve the patient's outcomes. And so these contributions towards the healthcare providers. Yeah. So we also can see the contribution from healthcare engineering in other subsectors such as medical equipment, medical supply, and healthcare system. So another sectors which is quite emerging now is biotechnology and pharmaceuticals. Yeah. So I heard now with kind of new engineering approach, the what the the time needed to um, produce vaccines such as this COVID-19 vaccine can be shortened because they get the help from the what the simulations, the software that can predict first and then they do the wet labs later. Yeah, so really healthcare engineering is emerging now. Yeah, of course, in healthcare consulting, because software quite a lot help this healthcare system, healthcare education, and healthcare support. Okay, we already talked about the healthcare applications. So the main problem with this healthcare application is their standards. Yeah, so there are so many, plenty of mobile applications available in the markets, but uh, you can realize later on that one system is not uh, interoperable with other system. Yeah? So it's always have a problem between one hospital to another hospital because they purchase a different software or different system with a different standard. Uh, it's not only between hospital, even in one hospital, it may has a different system, from one department to another department. So this also causing problem in integrating the system. Yeah, but luckily in 2011, the standard, what's so called health level 7, HL7, is evolving towards resorts for healthcare, uh, and then further evolve into fast health interoperability resources, FHIR. So this is the newest standard, and seems the the US willing to adopt this standard, and they start to push to the rest of the world to follow this standard. So hopefully with this standard we can, have a better interoperability among the healthcare system, or even if we can transform all the applications to use this standards. Yeah, this is a new standard for a better interoperability in digital health, and this is based on web technology. The main idea is to build a set of resources and develop HTTP-based representational states transfers APIs, yeah, to access and use these resources. So hopefully, if all applications use this standard, interoperability will be better. Yeah. So this standard also has unique and complete items if we compare to the previous versions of HL7 and HL7 CDA. So this is the general architecture of the standard. Yeah. So this is HTTP based using REST API. Okay, we move now to AI. We start with the definitions. Yeah, what is AI? If we ask people on the street or people on the workplace, so they will think about their jobs. Why? Because this technology, the AI technology, will cause the widespread disruptions on business model as well as on labor markets. Yeah? So they are worried that robots with the intelligence capability will replace them and they will lose their jobs. But I believe as a lecturers, as academics, it's difficult to replace, our duties, our jobs with robots. Yeah? So education still needs lecturers, still needs professors. No worries. Okay, so I think this a good approach to introduce AI through the movies. Yeah. So if you remember these movies, in this movie they use AI to play around with times. Yeah. And then of course this movies full of AI where the humans try to translate their language to aliens, and of course the shuttle, what do you call, the outer space plane equipped by all this AI based technology. Transformers also, because all is about robots with some intelligence inside. And this movie is also related to humans' life, half man, half robots. It's a conflict on the robot itself. And the last one is this one. I believe you like these movies. And in these movies, there is one skins at the beginning where an agent scan the face in the train stations to recognize the targets, right? So this is what they call image recognitions, but using stream video input, right? So the camera as an input for the vision, they put in the contact lens, and I don't know whether the chips or they send to the mainframe to process and recognize things. The agent successfully got the targets, but when he went out from the stations, he was killed by the enemies because the teams that sends the data for the enemies uh, got a problem with connections. It's delay and he got killed. So this is a good explanation of AI. Okay, let's go for the official or definitions of AI. Yeah. So according to Oxford Dictionary, intelligence is the ability to learn, ability to understand, and ability to think. Yeah? Then the artificial intelligence definition is the study of how to make machines make things which at the moment humans do better. For example, in terms of recognition, inferencing, decision making, abstract thinking, and learning new skills. I believe you all, when you were kids, you learn how to ride bicycle. You learn how to recognize uh, what toys, for example, yeah, or you learn how to swim and so on. So this is all about learning. Okay, some AI techniques that currently being used, I try to categorize some. First is soft computing. It includes evolutionary algorithms, genetic programming, yeah, neuroscience and neural net system, fuzzy set theory and fuzzy system. So all these three, sometimes they call it uh, connectionist system, yeah, and also chaos theory and chaotic system, because scientists believe that in the universe there is a chaos there. It's kind of random but has a patterns. Another category is I call it bio-inspired computing or nature-inspired computing. This one include ant colony optimization system, Firefly, bees algorithms. It's all for optimizations, and of course particle swarm optimizations techniques. Yeah? And of course, we have this computational logic to for proving for what they call, yeah, specifically for logic. Yeah, this is I call it a pure AI. Okay, um, we go through an example in bio or nature inspired computing. Let's see first on this ant colony optimization. Uh, yeah, this is a probabilistic techniques to solve computational problems and to reduce the space to finding a good path through a graphs. So the ant is an agent, and this is a multi-agent system, and the algorithm based on the nature of this how the ants communicate each other through what they call pheromones trails. Yeah. So once ants will send these pheromones, and then others will trail these pheromones to go from their nest to the foods, yeah, of source of food. So this is the illustrations where ants goes for foods and then produce pheromones, and when they go back to the nest, they also produce the uh, pheromones, and others will follow this, will trail this one. So this is the idea. So shortly, we can have this algorithm. It's general algorithm for ACO. But of course, there are so many versions that improve the performance of this algorithm. Yeah. So the next one is the Firefly algorithms. I believe you know what is Firefly. Yeah? So it is a meta heuristic then proposed by Young in uh, 2009. Is quite recent, and this algorithm search the best solutions, and this is based on brightness of the flash of the fireflies. Yeah, so the algorithm is quite simple. If two fireflies flashing, and then the less bright firefly will fly towards the firefly that flashes much brighter. Yeah? If the two firefly flash decrease, then uh, they they've tried to find another fireflies that have uh, a brighter one. Yeah, and the move is random. I never see these fireflies here in Saudi. Okay, so this is the algorithm. I'm not going to discuss further. Um, and then the next one is BET algorithm. This also meta heuristic algorithm, and to search to find global optimizations, right? Developed by Young also the next year. So I think he likes very much these flying animals. So how this mechanism works? Well, actually, bats communicates using this sonar, yeah, and they can search their prey and distinguish two different type of insects, and even in a complete darkness with help of echolocations using sonar, yeah. And also they are able to avoid obstacle using this one. Yeah? So this bat will send the echolocations, and it will echo back the sonars, and he knows the distance, he knows the directions here, and also can avoid the obstacle here by sending this echolocation. So
Jangan foto.
okay, so sorry, I also skipped this one, and we talk about the bees algorithm. This one also inspired by the bees that they're looking for nectars as a food, yeah, and the material for producing honey. Yeah? So, and they communicate each other at the hive via waggle dance. So this is the waggle dance. Yeah. So then with this dance, actually a bee informs others on the directions, the distance, and quality of the food source. Yeah? Okay. So the objective is to locate and explore the food sites within a problem search space. Yeah? This developed by Yuche in 2013, but I saw some works before that. Yeah? And okay, this actually the models. Of course, the bees never, measure the angles, right? So no, this is the model of this nature behavior on how the what they call the scout bees inform or communicate with other bees. Yeah. So the algorithm is actually mimics the foraging strategy of honeybees to look for the best solution to an optimization problems. Uh, food source, which is flower, is actually a solutions candidates. Yeah? And the populations or the colony of the bees is an agent, a multi-agents. Yeah? And these multi-agents will collaborate to uh, detect the shortest paths and the optimum uh, on getting the foods or the nectars. Okay, this is the algorithm. So in this case, we have three types of bees: yeah? Employed bees, uh, onlooker bees, and scout bees. Yeah? So the communication happen between scout bees, onlooker bees, and employed bees. Yeah? So this is how the scout bees do the waggle dance, yeah, to inform the employed bees on the directions and the distance as well as the amount of food here. Yeah. So uh, yeah, so actually these scout bees, you know, will inform others when the what do you call the source here almost finished or complete, and give the new directions of the a new source, yeah, to the employed bees, and also give the directions to the nest, to the hive. Okay. Particle swarm optimization is also optimizations techniques, but this one based on populations and stochastics optimizations. Yeah? This is motivated by intelligence collective behaviors of some animals, for example, flock of birds and schools of fish here. So how they collaborate. So it's quite old, introduced in 1995. We have populations, which is swarm, and we have particles, one individual, which is a candidate for the solution. So we model this into our problem until we get the optimum solutions from the candidate solutions. So the movements of the particles are guided by their own best known position in the search space, as well as the entire swarm's best known position. Okay, this is the algorithm. Okay, now I'm talking about how to model human brain, because we categorize this into the what they call uh, uh, a soft computing. Yeah? So from uh, brain model, we want to see how the brains process our informations, right? So from brain, uh, we model the brain as an actually brains consist of billions of neurons, right? And it's established a network, and the neuron itself consists of dendrites, nucleus, axons, and what else? Yeah, I think these are the three main components, and how they communicate each other, yeah, using signals from one neuron to another neuron. And from this, we come out with the neuron structures. Here we have a dendrite for inputting to the body here, and the body will uh, generate or will receive signals and as a synapses through the axons, and then send to another synapse. So we can come out with this neuron network model. Okay, the current, I mean, the most popular model is artificial neural network. Yeah. So these models, these neurons, we have dendrites, uh, bodies, and axons, and we model this one as a system that we don't know what's happening in the neurons. What we know, we have an input and we have an output, and we just sum up all this input with their own weight, and with one activation function, we produce an output there. Okay, this how exactly the we model the human brains, the process, mean the process in the brains. Yeah? So we don't know it exactly inside his this one. So this is the input, and we have weights for each input, right? And then we have what so-called transfer functions. It's just simply uh, sum up all these inputs, and using activation functions, uh, we predict the output, right? And then later on, we introduce a learning process. Okay, so the next concept in AI in soft computing is machine learning. This is an application of AI that provides system that able to automatically learn and improve from experience without being explicitly programmed. So we allow the machines, the program, learn from the environments. Yeah. So the aim is to allow the computers learns automatically. How they learn? There are two ways. One is back propagations. Yeah. So we calculate, we compute the output, and then compare, and then we force the system, the models to learn. Or we use feed forward approach. Okay, so in machine learning, we use all this usually back propagation training. Yeah, so we produce the output here. Yeah, we have three layers: input layers, hidden layers, and output layers. And the hidden layer only consists one layers here. So with the prediction output, we compare with the target, and we have the bias here, and we feedback to the hidden layer to adjust the weights, the current weights to the new one. We repeat this process until we minimize the error. Yeah? We got the close approximations to the target. Of course, we can do, if we don't have the target, we can compare the error with the previous one, but this one may produce a biased result. So we may have supervised learning, which is having a target here, or unsupervised learning without target. Okay, recently people talk about deep learning. So what is deep learning? This is a class of machine learning that uses multiple layers. That's the only difference. Yeah? In the hidden layer, we use multiple layers, and we extract higher level features. This is actually a filter for the raw input. Yeah? So instead of having one layer in hidden layer, so we have, let's say here, three layers. Yeah? What they call multiple layer perceptrons. Yeah? So this is the main idea. And recently, the most popular deep learning neural network is called convolutional neural network. So it may have so many hidden layers here, sometimes up to 128 layers. And actually the filters, yeah. Okay, some of them, they make it a block, similar block, a similar size of filters or layers, and so on and so forth. And at the end, we what they call we do the convolutions, and we use this activation function here. Sorry. Okay, let's see the current development of this AI techniques. Yeah. So I believe you know this speech recognition from Google Assistant, right? And then for object recognition from Google Brain Project. So the system can recognize, for example, vegetables in this wild image. Yeah? So many vegetables there. There is a human also. So the system can recognize this. And then smart presentations from Microsoft. Yeah, at the same time, the system will translate to the talk to several language. And of course, this self-driving car from Tesla, for example. I don't know whether it is safe now or not. And of course, smart manufacturing. Okay, so another concept is what's called evolving connection system, ECOS. So this one is a computational intelligence system based on neural networks and other combinations. Yeah? It also uses some of other computational intelligence techniques, operates continuously, and adapts its internal structures. So the internal structure is evolving, yeah, during the learning process. And of course, they also interact with the environment or other system. So this actually the integrations of neural networks with fuzzy or GA genetic algorithms, yeah, or computing of quantum computing, and as well as brain information processing. So this actually the the hybrid system. So the hidden layer is evolving. Yeah? So it is not fixed. Okay. Another concept is feature selections algorithm. This one is very important in disease diagnostics in healthcare or medical domains. Yeah? So we have three types of um, algorithms. One is filter-based approach, and then wrappers as embedded approach. So any classifications algorithm can be used to select importance and significant features in any system. Yeah? This one we use optimizations, and this one just produce the rank, and then we set the best features, and we select this one. It's very simple, and of course we can combine or hybrids all these approaches. Okay, some example of feature selection algorithms. For feature selection algorithm, we have information gain ratio, symmetrical uncertainty, relief F, 1R, and chi-squares. We can also use these classification methods, including bias network, naive bias, decision trees, G48s, and SOM. Yeah. Self-organized map of neural network. Okay, another example in the use of AI in healthcare is how to interpret baby cry. You know, a new parents, a new mom, new dads, they sometimes they panic, yeah, when their baby is crying. So this system can recognize what types of cry the baby is having. Yeah? Either hungry, sleepy, stressed, annoyed, or bored. Yeah? So interesting, we use AI on this. I believe, this is more on what they call signal analysis, right? The what's the volume, the pitch, the tone, the inflections of nerve juggling noise. Yeah? So we process this input and produce the 5 types of states of the baby. Yeah? Another example is also in maternity to monitor the unborn baby. So during pandemic, it is really difficult for pregnant women to visit their doctors in the hospital because it's a high risk to the baby as well as to the mother as well. So with this monitoring system, the mothers just only put the sensors in her belly or abdomen, and it will connect to the internet, and the doctor can observe, can diagnose, and uh, give some advices and so on, and can monitor the fetus inside. Yeah. So of course this one is very common to manage diabetes of patients, and it's quite popular here in Saudi. There's a lot of cases, and people in the rural area it's a bit difficult to to travel to the closest healthcare center or clinics. Yeah? So they use this kind of applications. It's a small sensor, sticks to the skin, and it check the sugar levels using the mobile apps. Yeah? Okay, so even in the application, they can contact to the doctors and ask for advice. Okay, so now we move to what we are doing, what we have done in our labs. Maybe I'm going to go a bit faster. Well, so now we are talking about memory predictions framework. So we focus on memory, not on the brain's modeling anymore. So intelligence is about learning. Yeah, if you remember when a kid learn to recognize cars. Yeah, so we give 3 example of cars. Yeah, the cars has wheels, the cars has windows, has doors, has lamps, and so on. Even the the shape is different, the color is different, but the cars has features. Yeah, so after learning, and the kids, we introduce a new car here, and of course the kids will recognize it is a car. Why? Because this thing has the features of cars, has the wheels, has the lamps, has the door, has the windows, and so on. Yeah, so we want to mimic this human brain in learning. Okay, the issue with the previous models of artificial neural network is fixed architectures, mean we have to set up in advance the number of neurons and their relations, right? Uh, and the second one is catastrophic forgetting. Uh, this also a problem with students. Yeah, catastrophic forgetting. You learn something new and forget the old one. Yeah, if the semester has 14 weeks, for example, you learn the first 7 chapters in the first 7 weeks, and then you learn another second part of the subject, and you sometimes forget the previous one. So this is kind of catastrophic. The fail of the engines to learn without forgetting the previous learned things. Yeah. Okay, the historical goal of machine learning research was to give a sense of human intelligence into machines, human intelligence. Yeah. But current intelligent machines still unable to perform tasks that is trivial to human brain. And the focus is more on engineering sides, the computational complex problems. Yeah, it is not exactly following the way human brain forms in intelligence from neuroscience point of view. So what we use here, the approach is to model the mimic, to model and mimic human neocortex, and this needs more neuroscience theory to explain how it works. Yeah. So another reason why we do this one is about because of these articles in Nature Machine Intelligence, they ask us to stop, think about the black box in neural networks. Yeah, so we have to come up with another models that more interpretables. Yeah? Okay, we start with how we model the human memories. Uh, we use this neocortex model. It is the largest part of the human brains, even in a mammal. Yeah? So neocortex is the biggest part. And this is actually the one that responsible to form human intelligence. Uh, Hawkins, in his book on intelligence, state this one, yeah, in 2005. So it's quite recent also. So he also introduced what's so called memory prediction framework. This concept is repackaging several neuroscience theories to explain the high-level operations of human neocortex and its role in forming human intelligence. Yeah. So this is more on memory, if I can say that one. Not only rooted in the assumptions of biology, but also makes sense in terms of computational point of view. So basically, uh, Hawkins introduced high-level theories on neocortex. So this concept has 6 layers. Yeah? The higher the layers, the simple they store. Yeah? So the deeps the layers, they store more details. Yeah. So maybe you experience one day you meet someone, you can recall, you can memorize the face, but you forgot the names, for example. Yeah. So maybe the face is a features, sorry, an object here. So you put in this memory, but it has relations, and the name is maybe somewhere here. Yeah. So once you trigger something that can uh, find what's the memory location, then you can get the names. Yeah, this happened, right? So this how he models the memories. And he also introduced what's so-called hierarchical temporal memory. This actually the theoretical framework that models several keys of computational principle of the neocortex in a human brain. So also he introduced a hierarchical temporal memory spatial pooler. Yeah. So this HTMSP models how neurons learn feed-forward connections and form an efficient representations of the inputs. Yeah. And it also converts the binary input patterns into what's so-called sparse distributed representation. So we can see the details later on. And it uses combinations of competitive Hebbian learning rules and homeostatic excitability control. So this is the HTM models. Yeah. So the main core, the core part is HTM spatial pooler, which converts binary factors into SDR. Yeah. And this as the SDR will be converted again into what the more representative in memory uh, and we use classifier to have the prediction. So this why we call it memory predictions framework. Yeah. And then um, we use a single layers in HTM network, and it's structured as a set of mini columns, and each mini column has a set of cells here, right? So it has a mini columns here, and we really model the neurons as uh, HTM neurons model. Yeah? So this neuron is modeled as a HTM neurons model here. And this one is really represents the properties of these neurons in the uh, human neocortex. And the excitability of these spatial pullers depends on its past activations functions or frequency. Yeah? So we use also activation function here. Okay, so in our work, instead of using HTM, we introduce single cell assemble sequential hierarchical memory. Yeah, so this is the single neural cell methods. It has two managers here and the cell itself, and we place this in either layer 6 or layer 1 or layer 6. So all these single neural will be placed on these different layers. Yeah. So we have a sequence manager, we have main controls managers, and uh, predictions modulator here. Yeah. So we talk about episodic memory. So everything in the detail here is kind an episodic, an episode. So we memorize as an episodes. It's really represent the human's memory. So this is the the illustration of the single neuron cell architecture. So we have some parameters here, energy, and then other thing. So we use this gene structure, energy, the matching rates to fires, the learning rate, as well as the weights, yeah, from the input. So the energy is actually in the cell itself. So, and furthermore, we simplified the sequential hierarchical superset platform here from 6 layers into 4 layers. So why? Because we want to have a real times monitoring system. So we need to simplify this memory models, yeah, because the HTM using 6 layers is quite consume a lot of computational resources. Okay, how we implement this one? First, we implement this in cybersecurity to identify the user behaviors among the insiders. So yes, so this is the problem formulations. This an enterprise, a typical enterprise network. So they are behind the firewall. So if the attacks come from outside, the firewall will block and the system, the network is safe. But what if the intruder already inside? Yeah, so the attackers already inside the network. So this firewalls no longer functions, right? And I believe you know this problem last time, ransomware, where someone puts or lock the data and ask for money to pay, then they release back the data. And also the case in Yahoo email, where during I think 4 or 3 4 years, they don't know that 5 millions of Yahoo email being hacked or steal. Facebook also, the private informations, some of uh, malware just takes the information silently, because Facebook give the API to crawl the data from their users, right? And my experience also helping the Baha University network in terms of availability. One times, the availability of the network is very bad, and we found out that they create a virtual servers, and I don't know where the malware comes, and this malware set up their own virtual servers and start creating the network, and the network becomes saturated. And maybe you also hear about the news that I don't know whether he is a Telegram, yeah? Who is name? Danny Siregar, that complained his identity was stolen, and it happens that the insiders takes the actions. Yeah. So why this happen? Because they lack of insider attacks detection tools, or if they have, the accuracy is not there and delay observations. I mean, it happens, and then uh, the system administrator or security guys only knows later. Yeah, so it's a bit late. So what are the insiders attackers? Maybe the living employees, or the malware that intentionally installed by insider user. Okay, this is how we implement. Uh, the input is the traffic stream, and we create this special pollers to fit the prediction process here, and this is the memory models, and we use the activation function here, and we come up with the predictions, and we analyze the prediction here. And we implement this. We capture, I think, almost 2 months of traffic in our network, and then we replay the data sets in this topology. And we managed to profile each user, yeah, for several type of traffic with 1, 2, 3, 4 layers. And the system is able to classify the profile of 8 users in the network. We also implement the system to predict the spreading of COVID real time, but unfortunately the result is not so good right now, and I cannot show you, sorry. So the second project is the mobile app framework to focusing on application for resource pool setting community health. So we propose a framework. So we have disease data sets, and we do the pre-processing to clean the data. And then the framework has this core part, which is the modules that can select appropriate model of neural network, and we implement the selected models with the specific GUI design of the mobile apps because we targeting rural people, and the system can diagnose preliminary any disease, common disease in a rural area. So this is the just the to show you the design. We consider the discoverability and affordance criteria of the GUI. Yeah? We use for experimental purpose. We use a data set from University of California in Irvine, and we choose 9 disease, common disease in a rural area. These are the attribute as well as the number of instance in the dataset. And we set up the experimental using Java as well as this deep learning 4G as the library for the intelligent engines. And this is the hardware. And the results show that we can recognize 6 out of 9 diseases with very good accuracy, very good precision, recall, and F1 score. And we also, show the optimum models of the neural network that showing the number of hidden layers in the number of layers in hidden layers. Sorry, and the worst case happen in diagnosis the heart disease. Yeah. Okay, skincare system. This is a current project. We collaborate with PT Paragons, Wardah. Romi also involved in this, and he developed the engines. Yeah. So Wardah has these 7 sophisticated devices to measure the conditions of skins. Yeah. So we use AI engines, ECM, evolving cluster methods, fuzzy clustering, and k-means. So we want to see the correlations between devices as well as the correlations between the measurement and the ages. Yeah? So this is an example of data from PT Paragon. Involve more than 1,200 participants. Majorities are women, and their age range between 13 to 51 years old. Okay, this is the result, the initial result. Using the ECM, we managed to have 4 clusters of skins. And this is the distributions of the data in each cluster, and almost in the 4 cluster. And from this observation, we conclude that age is correlating, or age correlates to the moistures of the skins. Okay, I just talk about this one a bit, how we detect malware in mobile apps using the flying animal inspired decisions, which is bees, bees, fireflies, and bats. Yeah? The main objective to increase accuracy of mobileware identifications. And we focus on these attacks, root exploits attacks. This is the proposed methods. We have 4 stages: data collections, reverse engineering, feature extractions, and feature classification using machine learning. And we use these 3 feature selections: BAT algorithm, Firefly algorithm, and bees algorithm. Yeah, and we use multi-layer perceptron for this machine learning. And for this application reverse engineering, so we open these apps, the malwares in the apps. Yes, so with these attentions, using reverse engineering with these modules, and we got the Java files, and we search for strings, and we have the clean data. So this clean data will be processed by feature extraction as well as feature classification here. Okay, so we have these data sets, means the number of data here for the attacks. Yeah, we have 550 attacks, and we also takes from Google Play the non-malware applications. Yeah, so we choose 600, and these are the features, including these permissions, opcode component, API calls, blah, blah, blah. And we have 31 numbers of features, right? And from feature selections, we maximum we select 17. So the bad algorithm collect the 17 features. The Fireflies only selects 11 main features, whilst the Bees algorithm produce 7 significance and relevance features. Yeah? And when we classify the malwares, so the Bees algorithm perform the best with 91.48 accuracy and 0.1 false positive rate. So we conclude that the Bees algorithm is the best for these problems. Okay, the last part is what I think is very potential to collaborate. The first one is the deployment of the new standards, because these are very, very hot topics now in healthcare. We may focus on how we convert the previous standard-based applications, or even non HFL based applications. Yeah. So this one topics with a good topics, I think. Or we just develop. It's not research. Just develop application specifically for rural area. And also another project is the deployment of intelligent health or medical system application. Well, there are so many ideas actually, and we may adopt a similar idea that already exists in the commercial markets, and we just optimize them or use another engines, another intelligent engines to improve the performance, or we minimize the cost. The third project that I propose is the extensions of data representation models and further improvements of the simplified sums architecture. So the memory model, memory predictions models. Yeah. So because we aims for the real-time diagnostic system, so we have to to consider the simplifications of this processing. Okay. Another project is on data science in education. So I believe, I don't know, USU using words, but Moodle is a good model. And with all this data, we do the uh, extracting the features of students or type of studies or subjects or whatever, and we come up with a recommender system for new students or for weak students or even for good students, of course. But usually, excellent students no need to have recommendations, right? And also in data science, but in cybersecurity, this user behavior analytic is quite uh, emerging, quite challenging, and also the market for this one also still open for us to penetrate. Okay, so last one, I just want to promote my special issues in Hindawis Journal. This is Journal of Health Engineering. It has impact factor of 1.8 something. It's Q3 journal so far. And currently I'm the lead guest editors. Of course, I can help. And I know the APC, the article processing charge is quite high, but I try to contact them to pursue that, we are in the difficult situations. So they seems to be, agree with me to give like exemptions to these developing countries researchers. Yeah. Okay, that's all. Thank you for your attentions. I'm open for any questions or comments.
Okay. Thank you, Professor, for your presentation. It's been a valuable knowledge for us. And now we're enter the question and answer session. I've already listed two questions from the audience.
Mhm.
The first one is it possible to have the presentation because it's really interesting and the audience would like to have the slides.
Sure, sure, sure. How to
Maybe
I send to
maybe
you?
you can email me.
Oh, sure,
Yes, okay. I'll put my email on the chat box,
sure.
and then you can email me after the session. And the second question is from Mrs. Erna Nababan.
Mhm.
Um, Supervised learning of convolutional neural network can require very large amount of labeled data. Labeling thousands or millions of training examples can be extremely time consuming and costly. How CNN address this problem?
Yeah. Okay. You know what? Nowadays we have what so-called transfer learning. Yeah. Transfer learning is a concept that uh, we can use the learned system, the learned neural network from one domain to another domain. So we don't need to train from the scratch. So this is what so-called transfer learning. Yeah. So one companies already implement this in a real application, real world. So he used one engine, one CNN that already trained, already used for what they call mining, the uh, oil or other mining data, yeah, which is huge, which is millions of row of data, yeah. So they train and then he just simply adopt this learn engine and implement in the business domain and it works. Yeah. So well, that's why I believe, I can produce a real-time system using these memory models. Because what? Because for the training sessions, we can adopt this transferred learning. So for the computational part, yeah. Hopefully this
Okay,
one.
so the solution is one of the solution is to use an engine that's has already learned from huge data instead of doing it from scratch. Is that right, Professor?
Yes, this transverse learning is actually the concept from this what they call educational or psychological psychology domains. If you learn languages, for example, you learn French, right? And then you learn Spain's language, for example. So you have already learned some basic structures. So when you learn another language, so you just use the previously learned model there. This is the analogy.
Okay.
Mhm.
Okay, thank you, Professor.
Mhm.
I have a question. Well, actually, this is a little bit personal because my wife is currently studying. He's trying to get his master degree in what do you call it? Skin specialist in doctor and medical.
Oh,
And I'm interested that you said you're currently having a project with
yep.
Wardah,
Mhm.
which is based on skin disease. Can you share a little bit about your current research? Maybe I can have an idea to share with my.
Yeah. Okay. 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 My colleague is Dr. Reza. He is from I forgot the centers in medical school in Universitas Indonesia. Yeah, but he is joining University uh, of Defense of Indonesia, Unhan. Yeah, so he is experts in dermatology. Okay, this current projects is actually because we collaborate with cosmetics company. So actually this is still secret.
Okay.
For time being, so uh, we start with the what they call uh, what do you call to determine the characteristic of Indonesians' skins. Yeah. This the first what stage. It's very at the beginning. We are very at the beginning stage. So now they have the equipment, right? They have very sophisticated equipment, and now it's just only for what they call the investigations of the type of skins in Indonesia, because PT Paragon also has what they call the what the benefit from this one, right? Because they can adjust their cosmetic products based on our research outcomes there. Okay, so the next stage is to develop the what they call the uh, the apps to give like recommendations or advice, on the skin's problems, yeah, or maybe before that one, the apps, the system will be used by what they call the marketing or the sales staff to to analyze the client's skin conditions, right? Using the mobile phone, right? So I think Romy has done some work on this, on the skin recognitions and so on. This the second stage. So we are going to develop kind of expert system, yeah, and then implement in a mobile application. The third part the third step, because we divide this in stages. Yes, the disease, the skin disease. But this one, I don't know the next stage, whether PT Paragon will allow researchers from the research group in uh, Universitas Indonesia to to record the clinical data. This one's Why we start with this, because to use the clinical data, we have to have like approval from the ethical council in Indonesia. So we are waiting for that one as well. So this is the step. So hopefully when we reach that stage, we can inform you. And I'm very, very, happy to collaborate with your wife, because maybe the geographical aspects also what they call influence the condition of skins, the disease, and so forth. Yes, I don't know whether this one answer your questions or
Yes,
not.
yes, it's actually answered my question, but a little bit follow-up question. Is there actually any applicable solution from, for example, the implementation of AI or machine learning in medical or specifically in dermatology? I mean,
Yeah.
has they actually used that kind of technology? Because considering the error rate is probably above 1%, is it acceptable in their standard?
Uh, yeah. Okay. I'm not so sure, because maybe the number of data is not enough. But PT Paragon keep collecting the data. I believe if the data is huge enough, so we can minimize the the error and increase the accuracy. Yeah, I think 1,000 multiple how many? 18. So 18,000 is not huge enough, And this data is specifically in specific regions, So I believe, when we have more details, more complicated data, I believe the accuracy will be increased. But the problem later on, how to implement the engine into the mobile apps, because my worry is it will consume a lot of computing resources when the. But for recognition, I think it's not so huge consume the powers. But my worry is if we implement the memory predictions framework, so when the system needs to do the learning on the fly learning, it may cause the power of the handphones, the smartphone. But this one can be easily overcome by what they call strategy of edge computing, where the heavy load of computational process will be offloading to the nearest servers, for example. But accuracy can be increased by the number of data. I believe that.
Okay, thank you, Professor. That's really good to know. Because I always wonder why, for example, for a skin disease where you can actually see the disease instead of your internal organ, why the mobile app that can actually automatically detect this kind of disease is very rare. And actually, I don't even recall any application that is able to do that commercially available in the market. That can or do you know any application that able to do that? I mean, a mobile app that can detect disease and it's actually commercially sold to the public?
Correct. Yeah. So this what we discussed with Dr. Reza. That's why this field of research is really uh, emerging, and we have so wide opportunities to come up with a proper system to overcome to address the problem there. First, we need the expertise, right? Secondly, we need the data. So yeah, actually, we have a roadmap for this. I cannot show you here right now because we still in the really in the beginning process, but we have the roadmap for this one.
Is it possible that we can swoop in during the process? Some of our researchers are probably interested in this kind of research.
Sure. Dr. Reza is really, open-minded person. So he welcoming, researchers from every place, from computer science, from medical science. Even he also collaborate with some statisticians. They try to to analyze the data through statistical approach as well. Uh, that's true, that's why this is really challenging, when if we can come up with tools that can help people to have a preliminary diagnostic results, especially for this what skin cancer, uh, acne problem. Yeah, so yeah. Mhm.
Okay, thank you, Prof. Well, actually, the next question comes directly from my wife, which is sitting next to me. She would
Okay.
like to ask, what is the best topic in a skin problem that is actually become the trend, the current trend? I mean, what kind of disease that actually become the trend today that most researchers try to solve the problem?
Yeah. Well, actually, our group already, done so many research papers in our repository, but mainly, okay. So this skin's problem, I saw they are not so what's I can say, it's difficult to be a global issue, so they have like regions by regions. I saw some journals, they're specific in Asia, dermatology journal, so they address issues related uh, related to skin's problems in Asia, and they have Europeans, specific journals. They have also Pacifics, or that's American journal on this one. So when I read through all this, just skim, the research topic. Yes, they are in dermatology, but they're specific in their regions, Uh,
So
uh-huh.
this is in a specific region. So that's
Yes,
the probably
yes,
the best topic
yes.
to carry
That's
forward.
why that's why your wife has a lot of opportunity, because if the data is what they call specific in the regions, so the originality of your work is really high. Mm.
Oh, that's interesting to know.
Yes, this why Dr. Reza, my partner, my collaborators, is really enthusiastic to develop this. Even our plans also later on, this data set will be publicly available, but it is not disease. It is just a characterization of Indonesians people skin, right? So this another approach to make our institutions being visible in in international community, right? If they want data on skin in let's say, tropical area, they will refer to our data center there. It's like the Irvine, California University. So this is why we collaborate with Unhan and UI as well. Or if USU wanna have this, you know, data center is really good. But the problem, you know, the equipment is quite expensive.
Just for curiosity, what kind of skin data that actually you collect? I mean, is it like a gene or color or?
Yes, correct. If you see here, the what they call the device we use here, we have 7 devices.
Oh,
Yeah?
okay.
So mixameters measure the pigmentations, sebumeter, the what they call what is sebum? My goodness. Okay, corneometers is a kind of moisture level, cutometers, the elasticity, colorimeters, the skin. Yes, all of this. This is why I heard this is quite expensive, and they have a complete set of these devices.
In UI, Universitas Indonesia,
Now,
or
in PT Paragon.
PPT Paragon. Okay, very interesting to know.
Mhm.
Do you think any of this can be detected using a mobile phone? Maybe colorimeter using a camera and mobile phone? Is it possible to do that?
Yeah. Later on, when we have already the what they call the engine to detect the level and so on, we can have the engines that, you know, from the image we can you know, classify this, right? In which level of this what they call hydrations, right? So because we come up with a cluster here, right? For example, in this result, right? So we have 4 cluster here. Okay, the cluster 1 is kind of you know, a normal phase. Oh, sorry, it's too moist, right? Uh, so we have like groups of skins that have low moisture level, mediums, high mediums, high, or very high. So something like categorizations. That's why we use also fuzzy clustering to come up with this one. So the problem later on to you know, to convert the image from the handphones, right, to the format of this uh, uh, this data, right?
Interesting.
Mhm. Yeah.
Okay.
That's another stage to convert from image to this what they call numerical data. Yes.
Okay. Thank you, Professor. It's been good to know this, and I will definitely share this with my wife. She'd be very interested in this data.
Sure.
Uh,
Mhm.
is there any more question from the audience? I don't think there's any more question. Maybe later, if someone has a question, they can pass it to me, and then I'll pass it to Professor Ahmad Budriato to be answered even after the session is over.
Yes.
So I think, do you want to add anything else, Professor, before we close the session?
Yeah, this is my email. You can contact
Okay.
directly. Uh, and I have email in Universitas Al Azhar Indonesia because this is my future place.
Okay.
Yeah, and then another things, please consider this one. So you can consult with me. What is the requirements? What is the expectations of the journal? So I'm
Okay.
really open for this.
Okay, maybe you can share me the PowerPoint so others can see the link from, because I cannot copy the link from the slides.
Yes. Okay. So this is the link, yeah.
Yeah. Okay, Professor. If there's no more question, on behalf of the Faculty of Computer Science and Information Technology Universitas Sumatera Utara, I would like to thank you for your availability to become our presenter in this general lecture. And it has been a very valuable knowledge for us, and we wish we could collaborate in the future. And hopefully we can see you in our future event. We wish you all the best in your future endeavor. And you're saying that you're moving to Al-Azhar University in Indonesia?
Yeah, because I'm 60 next year.
Okay. So next year you'll be staying in Indonesia?
Inshallah. But
In Jakarta or?
Yeah, Jakarta.
Okay, then we're probably going to meet you more often.
Hopefully.
Thank you, Professor. Good luck for your work, and we wish you to see you anytime soon. Goodbye, and thank you for all the audience. That's all for our event today, and I will see you in our next series of the Visiting Professor series. Goodbye.
Bye.
Thank you, Prof. Rahmat.
Oh,
Thank you, Prof.
oh, wait a minute, Prof. I think we have to take a picture, online picture.
Please. That's important.
Please, for all the audience, if you could please open your camera so we can have a photo through Zoom. Oh, Pak Romi is already joined the conference.
I'm sorry, I'm very late. Thank you, Prof.
Thank you, Romi.
Thank you so much, Prof.
Romi is a busy person now. From another meeting.
Yeah, Prof.
Okay, audience, please kindly open your camera so we can have a photo session in the Zoom. And Pak Indra yang ngambil atau saya? Sama aja ya. Okay, please hold a moment. Okay, 1, 2, and 3. One more time. One, 2, and 3. Okay, thank you. That's all for today. Thank you for your participation, and we wish to see you on the next series of the general lecture, of our general lecture. See you.
Okay, thank you, Prof. Thank you.
Thank you.
Thank you, Bu Maya.
Terima kasih sama-sama, Prof.
Terima kasih banyak. Prof. Rahmat, Kak Leli.
Bu Leli masuk ya?
Ada
Masuk.
instructor.
Sehat, Bu.
Prof. Syukur. Terima kasih, Prof. Syukur.
Prof. Syukur juga ada.
Ada nih, Prof. Syukur.
Oke. Tuh, sibuk ya, Bu Maya?
Ya, sama-sama, Prof. Izin live, Pak.
Oke.
Prof.
Ya, insya Allah kita kolaborasi ya.
Okay, so next year, Prof. Maybe another program, visiting professor.
Oke.
Ya, mungkin join publication or join supervision, Prof.
Sure. Ya, saya sebetulnya punya target ini untuk apa namanya jurnal healthcare engineering.
Ya, kita juga ada jurnal sebenarnya, Prof. Jadi mungkin bisa kolaborasi, ada jurnal fakulti, tas, Jocai. Kita mau ke Scopus itu, jadi